Okay. Hello and welcome to the stream. It looks like we're getting a few people dropping in now. We're up to about 14, so that's good. Um, Hopefully everybody can hear us, and we are very much looking forward to the conversation. So it looks like we're going to have a very interesting group of people joining us, aviation enthusiasts. So we're really looking forward to the conversation. Michael and Paula, we're looking forward to the. Are you guys looking forward to this?
Definitely. I was really excited to see how many different kinds of people registered for this event, people from all over the industry. And it's just really cool to see the interest in this great project.
Well, great. And it looks like it is functioning as expected. So let's kick it off, Paula. If you want to get us rolling down the hill, and then we'll answer the questions that we got and see where this takes us. And hopefully, those of you online will be asking questions, and we'll try and answer them. And if we don't, we'll get back to you.
Fantastic. So, welcome. We're really, really happy that you're here. While we wait for people to join, I know there will be people dinging in. Please take a moment to introduce yourself in the comments. Like I said, there's people from all over. Let us know where you're from, what part of the industry you're from, and what you'd like to hear during this series of events. We'll also cover a little bit of housekeeping while we wait. We're planning to spend about an hour together today, and this is not the last of the events that we'll have about DBT Aero, of course. Um, if you have streaming issues during the session, you can try refreshing your browser or rejoin, to click the link again to get back into the LinkedIn and refresh as needed. Of course, the event is being recorded, so if for some reason things don't work, with technology, we never know. You can always view it later at your convenience. So please use the comments feature throughout the session. It's located just below the video to ask your questions. And in our testing, we learned that there can be about a 30-second or maybe even longer lag between what we're doing on Zoom and what happens in the LinkedIn. So if it seems like we're not being responsive, please be patient with us while those delays kind of figure things out. So we'll start with really brief introductions. I'm Paula Williams with ABCI. We help aviation companies sell more of their products and services. And Michael and Ben are two of my very favorite people. We've been working with them for a number of years and really, really enjoy working with them on this exciting project. And Angel is also working with us today. She's going to be moderating the comments, so you'll see her in the chat or in the comments. So let me go ahead and allow Michael to introduce himself because I won't do it justice. I know there's a lot more to Michael than I know about. So.
Okay, well, thank you, Paula. Hi, I'm Michael Duke. I'm the CEO of DBT Aero. A little background about me is I spent nearly 20 years at the beginning of my career working in a variety of roles, including as a management and technology consultant and as an IT director for a Fortune 200 company where I developed an international corporate cloud computing network among some other innovations. The next 20 years were focused primarily in in aviation roles. The earlier 20 years were innovation. This is still innovative, so fun stuff. I purchased and turned around a struggling fixed-based operation, imported and distributed light sport aircraft, and finally, after 19 and a half years, completed my pilot certificate. So, woohoo, I finally did it. And don't give up. You can still become a pilot even at an older age like mine. In 2019, I co-founded DBT Aero to commercialize the ultra-efficient patented double box tail. I'm also focused on developing and integrating leading-edge, ultra-efficient powertrains and simplified vehicle operation technologies so that we will always have some of the most leading-edge aircraft that you can buy. And now I'd like to turn the time over to Ben. Ben, the mic's yours.
Yeah, thanks. Thanks very much. I do want to mention, I know when we've been practicing, this is our first Zoom live LinkedIn stream. So probably will be a few hitches along the way, but we are planning to do quite a few of these as we go forward. So any suggestions, you can stick them in the comments if you're interested in a certain topic or you want to talk about something in particular about our airplane. We'd be glad to at least consider the suggestion. There are some things we do keep confidential, but we'd love to talk about our plane. As Michael said, my name is Ben Nivert. I am the Chief of Staff here at DBT Aero. I've been with DBT Aero a little over a year, or a little under a year, and I'm really passionate about aviation. Been a pilot since I was in high school. You used to fly charter, did some flight instructing. It's how I paid for college. But I'm very passionate about aviation and air transportation in general, and of course, with our aircraft, specifically around regional transport, because I think that our aircraft offers some incredibly unique combination of technologies to make regional transport a more efficient, more affordable aspect of aviation than it is right now. My degree is in mechanical engineering, specializing in aerospace, and I have an air commerce degree and an MBA. And I started out working for a aircraft manufacturer at the beginning of my career. And then I worked in operations, process excellence, technology. I was an adjunct faculty at an MBA school. And as I mentioned before, I was a charter pilot, flight instructor, and a big chunk of my career as a consultant, specifically around operations and technology and operations excellence. So I'm really looking forward to our conversation, and I'm looking forward to talking about our airplane. And hopefully you'll engage and make comments and ask questions, and we'll look forward to doing what we can with that. Paula?
Absolutely. So we have received some questions in advance, so we'll start with those. But as a reminder, please type your questions in the chat. The more interactive this is, the more fun everybody has. And, of course, the more informative the session will be. So starting with a question for Ben, why are you developing this aircraft when so many others are already on the market?
Well, of course, as I mentioned, I'm pretty passionate about aviation and been down the road of developing a new aircraft for one of the major manufacturers before and loved it. And having looked at regional transportation for the last year, you really understand the hard economics of trying to move a small number of people to a small airport out in the middle of what could be almost nowhere a few times a day, if not once a day, or even only a few times a week. So we just believe that if we can change the operational cost and the operational dynamics, that we can create a much more affordable, more effective service that more players can make a profit at and not end up being subsidized on routes or reducing the services or charging so much that the folks in the region can't afford the tickets. The other thing is we look at this question in two ways. We're developing this aircraft. Yes, there are other companies that fly regional routes, and there are many aircraft that are used. But the other aircraft, the other way to look at it is to really look at the technology. And Michael's going to talk a little more about the technology as we go forward. But we're really excited about the capabilities that this aircraft and this design and this aerodynamic design will bring. So it's a very sustainable aircraft. It travels at a very high, comparatively high speed. It has a low operating cost. We believe we'll be able to manufacture it at a lower cost than the competition. It'll carry passengers, cargo. It has a fuselage that's a bit larger than most of the other aircraft in the field. So it means we can carry more cargo without running out of space before we run out of our useful load capability. It's also useful for a lot of other aerial operations like air ambulance, medical services, anything where you're trying to get a reasonably small number of people over a long distance in a short period of time, or carrying freight over a reasonable short distance. We're not talking about intercontinental, 500 miles kind of time, kind of distance. You're carrying that kind of load. We think that this aircraft is going to create some real unique economics. We are planning a fly-by-wire for the full line. And that means we'll be able to swiftly migrate from remotely piloted to optionally piloted to autonomous, along with our piloted aircraft as well. So currently, operators in the region are experiencing some real increasing operating costs and lower passenger volumes and freight volumes. So there's a real pressure here. And we believe that in services like medical services, they're facing increased needs and limited budgets. And we think we can really help provide those services at a reasonable cost that will deliver where others can't. And Michael, I know you had a couple of things you wanted to add, so perhaps you'd like to add a few things here.
Sure. Thanks, Ben. Throughout aviation history, many aircraft have been developed to address many different types of missions. And that's really been the driver. Different missions drive different aircraft designs. We started with biplanes. Those were followed with monoplanes. We have sailplanes for long distances, delta wings for high-speed maneuverability, cargo planes for large and heavy loads, seaplanes for water landings, flying wings, blended wing bodies, blown wings, joined wings, box tails, canards, and more. And yet there's really nothing like our double box tail. Our family of aircraft addressed the demand for a unique combination of speed, range, payload, and efficiency, as Ben was describing. There are currently aircraft that fly far, like sailplanes, others that fly fast, delta wings, and others that carry, significant payloads, the big thick-winged cargo planes. And yet our ultra-efficient family of aircraft, which are scalable from small hand-launched drones up to future commercial passenger airliners, combine the ability to fly far, fast, and carry bulky, heavy loads in a way unlike any other plane on the market today. So I think we've got a unique capability, and it addresses some missions that have never been well addressed in the past.
Right. So I know as you're thinking about these capabilities, there are a lot of really smart people from different parts of the industry here. And so everyone is going to see this differently. I mean, you're going to see this as an opportunity to do different things depending on what your problems are to solve. So if you have a great idea or an interesting use case, throw it into the chat. It may be something we haven't thought of. So next question for Michael. What are the technologies that make the DBT Aero aircraft really different from others?
Thank you, Paula. Our aircraft synergistically combines proven design principles in a way that just hasn't been done before. For example, the entire aircraft has been designed to allow smooth, non-turbulent airflow, which reduces drag and noise, since turbulence is noise. The large voluminous fuselage, as Ben talked about, increases the volume for cargo, but it also is great for passenger comfort. We all like a larger cabin in which to fly. Mm-hmm. And at the same time, that cabin, that fuselage, was specifically designed to reduce drag and provide some additional lift. Our patented box tail design allows for several aerodynamic challenges. Unlike box wings and biplanes, which create interference as they're lifting, our patented box tail design allows for positive aerodynamic interactions between the wing and the upper control surfaces. That's one of the things that sets our box tail apart from other box tails, which keep the control surfaces on their main wing. The precise alignment and spacing reduce drag, increase lift efficiency, enhance low-speed performance, and result in reduced wingspans. Also, the joined wing structure creates a very stiff wing, improving aerodynamics and structural integrity while reducing the empty weight. And while our aircraft appears really short-coupled, had that conversation with a number of folks, in actual flight testing, our box tail increases stability and safety. So we're seeing reduced yaw, and we're also not seeing the pitch or roll sensitivities that are typical of box wings. The pusher configuration reduces both interior and exterior noise, and we utilize it to help reduce some drag. And our aircraft are also propulsion agnostic. The manned proof of concept is currently flying with a traditional internal combustion engine, while our unmanned aircraft are battery electric. So our aircraft can be powered by internal combustion, turbines, jet engines burning aviation fuel, sustainable aviation fuel, or hydrogen. And we see that they'll be powered in the future by batteries, fuel cells, hybrid powertrains, or whatever else people come up with. And we're looking forward to working with all of those brilliant inventors who come up with amazing new propulsion systems. So we're really excited about the things that make us different, and we think it'll apply to many, many use cases and make life better for people all around the world.
Fantastic. Ben, did you have something to add to that, or should we move on to the next question?
Yeah, there's a couple of interesting comments about the rural, kind of the rustic parts of the country, and we are looking at servicing these areas, the part of the world that's not the major hubs. And we believe that there's a market if the aircraft is sufficiently economic, if we can provide a profit. I think there is some real challenges around the timing of getting this to market. Yes, we believe we can get to market in the next few years. We're not going to be specific now, but we believe that we can start small. We are looking at a range of aircraft from drones to regional carriers to build up data and confirm our information, our performance information on the four that we have, to make sure that it scales the way we think it will in terms of performance, range, and other things. So we're just thrilled with the combination of technologies that make this airplane work. You're looking at a wider fuselage, laminar flow. We're putting together a whole series of technologies, four really, that have a dramatic impact on the performance of the overall aircraft. So we're really excited about this. We think this can make a real difference in the regional market.
Right. That leads really nicely into the next question, which is for Michael. And of course, everybody knows that technological advances are great, but what it really boils down to is actual benefits for actual operators. So, Michael, what benefits do you see from this technology for operators?
And there are a number of benefits, and we focused somewhat on regional and regional operators. But remember, the technology scales from unmanned drones all the way up to those regional passenger aircraft. So as a general aviation pilot, and it took me, as I say, 19 and a half years to get there, but that's a story for another day. I'm really excited to fly one of these for my own personal flights and the benefits that come along with those. We're seeing a reduction in fuel or energy usage of more than 30% compared to aircraft of a similar wingspan. So that translates directly into operating cost savings and reduces fueling and charging turnaround times. So as a personal pilot, that's something that I'm really looking forward to, is flights that cost less. Using a similar size power plant, we're also seeing significantly faster cruise speeds. So together, these benefits lead to longer range, as well as more benefits. For passenger operations, the cabin, as I mentioned earlier, is more spacious, it's quieter, and the flights are smoother. And for cargo carriers, there's increased useful load, which translates into a lower cost per ton mile, and the larger cabin volume reduces the risk of cubing out before reaching max takeoff weight. Quieter aircraft are also good neighbors, allowing 24/7 operations into noise-sensitive airports. And our aircraft have fewer flight surfaces, less yaw, a reduced risk of entering a spin, and easier spin recovery. This reduces crew training and increases safety. And finally, for society, using less fuel conserves precious resources, and compatibility with sustainable aviation fuel cells, and battery and other future technologies will reduce pollution, and is just generally good for all of us.
Fantastic. Ben, did you have anything that you'd like to add to that? Any other benefits that you see that I know there are many, but what other benefits do you see?
Well, when we look at benefits, especially around this aircraft, we look at what we call first, second, and third order benefits. So the first order benefits, as Michael covered, it's a much more efficient aircraft to fly. It's laminar flow, the design of the fuselage, the double box tail give you an increased efficiency. That means for less horsepower, for less thrust, you get a faster plane, you get better climb rates. There's a whole bunch of first order efficiencies that just reduce the hourly operating cost of the aircraft. We're looking at production very carefully to try and implement best practice in manufacturing. And right now, a lot of aircraft are manufactured the same way they've been manufactured for at least the last 20 to 30 years, including the move to composites. We're looking at a very more advanced manufacturing process and management of our supply chain so that it's first order. The capex cost, the cost of purchasing it is going to be lower, and the cost of operating it is going to be lower. Then there's the second order benefits, and second order benefits are really surrounding the idea of reorganizing an existing network. So if you're flying freight, can I eliminate a hub because the plane flies farther and flies faster? So I can now reach more places from less hubs than I could before. And reducing a hub, even for passengers and other services, is a pretty significant cost reduction opportunity. And then we talk about third order benefits, and the aircraft offers opportunities to service markets that you couldn't service before. And we're really excited about that. That's really pushed out to the industry to say, hey, if you had this performance capability, what would you do with it? What could you do that you're not doing now that would be beneficial, right? Economically profitable and provide better services to a larger area. And there's a whole range of those that we've thought of, and we're pretty excited to see what the market's going to do once they get their hands on this aircraft and say, okay, it's less expensive to operate and purchase, and we've reorganized our networks to be more efficient and more cost effective. And oh, look, we can do this and this and this that we couldn't do before with the existing aircraft because either we had to use a jet aircraft, which we couldn't afford, or we couldn't make the leg work because there's no fuel at the far end and we can't get back. So there's a lot of great opportunities. And we think that the third order benefits really come out of this new capability that we're going to provide in this aircraft. So we're really looking forward to it. And we think there are at least, first, second, and third order benefits, and maybe somebody can point out something we haven't thought of. Right. So we're looking forward to hearing what the operators are going to do with our aircraft and making better money and providing better service.
Absolutely. So this is a specific technical question for Michael. How did DBT Aero confirm the 30% performance improvement over your competitors?
Well, we've done a number of things. We explored the performance improvements using several tools, including mathematical calculations, computational fluid dynamics, or CFD analysis, using computer simulations, and our own prototype flight results. Remember, the 30% performance improvement that we're seeing is using the same propulsion system as a similar size aircraft. So the efficiency improvement is from the airframe alone, not by changing the propulsion system. The efficiency of our airframe allows us to use, as Ben said, smaller, less powerful propulsion systems, which consume less fuel and energy. You integrate these smaller propulsion systems, new hybrid, electric, and hydrogen fuel cell propulsion systems, and we see that the performance improvements will compound, and we would not be surprised to see greater than 50% reductions in fuel required. So we're pretty excited as we start to marry this technology with all the new technology around propulsion systems. We think the future is pretty exciting.
Absolutely.
I will add to that, Paula, real quick, is when you look at the opportunity to use these new propulsion systems, one of the big challenges is you're trying to do, say, battery electric or even hybrid hydrogen type fuel cell propulsion. When you put it on a standard piece of aerodynamics, an aircraft that exists today with the aerodynamics that exists today, the effect is much less. So the challenge becomes that the batteries can only put out a certain level of power.
Mhm.
And in the current aerodynamic environment, that power isn't sufficient to provide a certifiable performance numbers for an aircraft.
Right.
Where if I clean up the aerodynamics, suddenly the ability of a hydrogen fuel cell, the ability of a battery to put out a certain amount of power, and I use a good set of hybrid propulsion system, suddenly what wasn't possible because the batteries would explode becomes possible because your draw on the battery is significantly lower. And it still provides a runway length you can accept. I saw in some of the chat comments, what's the field requirements? What's going to happen when you get out in the region? Well, we think this airplane is going to perform takeoff and land a lot like what's already out there, but better,
Mhm.
right? A smaller amount of propulsion is going to get you in the air in less distance than the existing comparable aircraft. So we think there's a lot of benefits to cleaning up the aerodynamics, which is what we learned, 100 years ago, and then 50 years ago, and then, 20 years ago. Every time you look at the aerodynamics and make changes, you get performance improvements.
Mhm.
You can't take a biplane and make it go supersonic at least more than once. I guess after the first time, there's not much left. But in this case, if you redo the aerodynamics and really look at it, you get some significant performance improvements.
Right. Understood.
And we see an analogy in the automotive industry. If we
Mm.
look at the move to electric vehicles, it went hand in hand with streamlining the vehicles themselves. As I visit, automotive museums, I love some of the beautiful designs from the 20s and 30s and 40s. They're gorgeous, they're elegant. But I could never see those as electric vehicles with the range and the speeds that we want out of our vehicles today. The only way you achieve that is by streamlining them, and that's what we see in the line of Tesla automobiles. So our focus is that streamlining and producing the world's best airframe, that we partner and integrate the world's best simplified control systems and propulsion systems and provide the industry with the best aircraft that are available.
And to add to that, the manufacturing processes have all changed. And I have spent some time in the automotive industry making cars. And when you look at what they're building, these cars are structurally stiffer,
Mhm.
they're significantly lighter, and they're designed specifically to run electric motors and carry batteries and passengers. So the cabin sizes have increased.
Yeah.
So suddenly it's more comfortable to ride in them. Insulation requirements have changed dramatically. Now all of a sudden car companies have to introduce noise instead of trying to get rid of it, because otherwise you can't tell if the car is coming, you can't hear it. So
Mhm.
this is very different. And we're looking at all these aspects, the aerodynamics of the aircraft, the manufacturing of the aircraft. We're talking to propulsion developers and manufacturers to understand where we can optimize that. And when you put all that together, you get something quite spectacular.
Absolutely. So, speaking of those traditional aircraft, those
Mm.
Model Ts and things like that of the aviation world, not that these are Model Ts, but they are traditional aircraft. What aircraft were used as the benchmarks for your testing or for
So
benchmarking?
yeah, well, I mean, I'm a general aviation pilot. I was a flight instructor, but we
Yeah.
looked at a lot of aircraft in the industry as a comparative. We looked at some Beech, some Cessna, Cirrus models, Diamond, Piper. So we really looked across the board at anything you might use in the general aviation market as a comparison, because we do think there's a market for a general aviation aircraft. But we
Mhm.
also think there's a real significant market and a driver for change across the region, the regional airspace. And Michael might mention some of the areas we looked at in comparing our aircraft to the aircraft that are currently used in the regions. And I know one of the things that when we look at that market, there is some benefits to reducing the number of types of aircraft you operate. So we looked at the best competitors and said, oh, we can outperform them. And Michael will talk about that. But we also think we can cover a wider gamut, which means an operator flies less types of aircraft. And anytime you can fly less types of aircraft, you can save money. So I think Michael might want to talk about where we compared it to in the regional aircraft size, and then we can carry on from there.
Sure, thanks, Ben. So certainly standardization is very important, and that's one of the things that we're seeing with the large commercial airliners. They standardize on certain models, and that simplifies their maintenance, lowers costs, easier for spares and logistics, things like that. As we look beyond a personal aircraft in the general aviation space, we begin to look at the workhorse for cargo operations and also for many regional passenger operations, and that's the Cessna 208 Caravan. As we look at that and the applications that it's used for, we believe that our larger cabin, higher cruise speeds, increased efficiency, leading to lower costs, the quieter operations, as well as the easier pilot training and the safety will offer significant competitive advantages. And we look forward to bringing to market something in that size range as we continue to grow the family of aircraft from small personal up through a regional and into larger aircraft. And also, moving down into unmanned drones. So we're looking at all different types of sizes of aircraft in the family, whether we build those or whether we partner with people on those builds. We believe that this technology is going to spread widely across the industry, and this will become a common shape in the near future.
Right.
To add to that, somebody asked where we're targeting. We're a startup, and as any startup, we're willing to entertain opportunities as they present. Right now, we believe we can have the biggest impact in two spaces. One of them is regional delivery, meaning medical supplies, urgent deliveries. And we also believe we can have the biggest impact in regional passengers and piloted freight. So there's a couple of different areas we're focused on. We know there's some other opportunities. We have been talking to some folks about surveillance, about military applications. So we're pretty open right now to what we can do with this design. Like we said, we're really anxious to talk to people about opportunities and what they see this performance could do that we haven't thought of. But right now, when you look at the challenges in aviation, one of the biggest challenges is economic regional air transport.
Right.
And that is driving companies out of business. If you look at that space over and over again, companies come and companies go. And biggest problem for them is the economics. They have to live on it. Many of them live on subsidies. And if the national government of whatever country it is isn't committed to regional services and willing to provide subsidies and infrastructure money, many times the regions just don't get it, don't get the air services. And in some cases, charities come in and provide it. But that's a tough step for a charity.
Yeah.
There's just not that much money in charity to provide the service if you don't have a national government. And don't forget that American airspace was started by government subsidies for postal service. It's not a crime, but you do need to make a commitment to these regions. And we think if we can provide an economic aircraft, then they can be self-sustaining and we can provide these services.
Right.
As you mentioned, Ben, there's lots of different opportunities. We believe that the regional is certainly one of the key ones which we are targeting, and that's something that will take us a few years to get to that point where we can provide a certified aircraft to meet that demand. As the saying goes, the fox that chases two rabbits goes home hungry. And so there's so many opportunities, we could end up going hungry. That's why we continue to look for opportunities to partner with people who have a particular expertise in various markets. And as such, for example, in the unmanned, I'm a private pilot, so I know the unmanned less well, and we're open to partnerships and working with people that would like to bring us into certain markets, and we are working on that. So don't expect us to try to conquer the entire world all by ourselves. Our focus is partnerships and working together with lots of smart people to bring the aircraft and the benefits of the aircraft to many different markets and many sectors of the world and in aviation.
Right. So that leads into the next question. So you've kind of partially answered this, but it all boils down to the economics of the challenges you see, for bringing this to market. And, what challenges do you anticipate for scaling production to meet that market demand?
We're pretty experienced at aviation for the group of us. The team has deep experience in airframe design, system design, manufacturing, supply chain, management, leadership skills, finance. So we think we have a good team. We're committed to that team. We believe we have a great team. And we expect the biggest challenge is going to be in three spaces, really. One of them is, as Michael pointed out, attacking the market in a organized fashion. We have to be sure we're focused.
Yeah.
If we never chase two rabbits, but we do believe there's a stepping stone approach that sometimes catching the first one helps you catch the second one, if you pardon the analogy. So there's some ability there to stay focused in the sales and marketing side. And when it comes to manufacturing, we are building relationships with assemblers. We're building relationships with suppliers. One of the challenges that we are looking at is training staff for the assembly process. We want to be sure that the staff is extremely well trained, and that takes time. And we are developing mitigating strategies to make sure that all these risks are managed in advance, planned for, so that we don't end up with more than the usual number of surprises as we get into production. But we think we have the right team. We know we can create the right partnerships, and we know we can face and mitigate these challenges to getting into production. So we're really looking forward to it, and that's where we are right now, is building those detailed plans and building those partnerships and making sure that we have all the right mitigating strategies in place to face the challenges that are going to present themselves to anybody trying to make almost anything, especially aircraft.
Right. The next one is a little bit of a generalization of several of the questions that are being asked in the chat, but maybe you can conquer this first, and it may answer some of those that are filtering in. And again, if you have a question that doesn't get answered today, don't despair. This is the first of many events and so on. So Les, Dennis, Michael, and a few other people have asked variations on this one. But what are the most significant technical risks currently facing the project?
We've addressed a number of the risks, and that's part of R&D, is to minimize risk and check the boxes that say, yes, we're ready to move to the next stage of development. So our current proof of concept aircraft, 4 of them, have demonstrated that the complex shapes that we need can be manufactured. The technical challenges that we're working on right now are developing, as Ben was talking about, the manufacturing processes for simple high-speed manufacturing of the complex shape, the composites, etc., in volumes that will allow us to meet the projected demand. We think that these will be coveted aircraft and highly in demand as we bring them to market. Also, underneath the beautiful exterior, some very special things are happening. We can't talk about those at this time, but identifying the suppliers and procuring those special things in production volumes is another technical challenge that we're currently addressing. As we solve these more immediate production challenges, because our focus is to get to market quickly. We would like to turn our attention to integrating future propulsion systems and simplified flight controls, because as I said earlier, our goal is to offer the most efficient and advanced aircraft in each market that we enter.
Fantastic.
We are looking at advanced manufacturing capabilities that exist right now, but we also have our eye towards certification. So we are looking at materials that are already certified, so that we don't have to recertify a material, which adds quite a long time, or certify a new material, which adds quite a lot of time. So we believe that there's plenty of opportunity to leverage new manufacturing capabilities, new manufacturing processes. There's also some really interesting capabilities in using solid models and what they call digital twins. The idea of creating a digital aircraft that looks like the aircraft, connecting with partners and allowing them to make major subassemblies that we know are going to fit together on the assembly line. And I can tell you, in manufacturing, when I was in aircraft manufacturing, there's a lot of parts that even made in-house show up on the assembly line and have to be re-drilled, ground, fried, hammered, all kinds of challenges in getting the pieces to fit together. And a lot of that capability in manufacturing now to make a precision part exactly the way it needs to be, precision manufacture a subassembly, and then have that assembly basically snap together very close to,
Yeah.
is quite in the scheme of things right now. And that's going to change the dynamics of making an airplane. And we think people aren't looking at the holistic manufacturing CapEx, OpEx combination the way that we are.
Right. So I know there is a balance between being responsive and transparent and, building relationships in a tentative sort of way. So you may or may not be able to answer this very much, but here's a question. Up to you how much you answer it. Have there been any preliminary discussions with operators or fleet managers about adoption?
Yes. Yeah, we can't be too specific here, but we have talked to several operators who have expressed a very enthusiastic interest in the aircraft. And we are working on assigning a launch customer or launch customers. So we're certainly focused on that. We think that there's a lot of opportunity when you partner with the user to design the aircraft better than you would if you have to use a theoretical customer. So we're very focused on finding those launch customers out there. And if somebody knows somebody we should be talking to, or you're an operator and you're interested, we hope you'll reach out. But we've looked at a few places. We've done some cost modeling. We looked at a freight carrier and we said, wow, if you look at this freight carrier and you replace one aircraft in their fleet, which they have a fair large number of, you might save $100 million a year in operating cost. And we looked at some other opportunities that isn't freight, it's a service provider. And we thought, here's a group of people with a very constrained budget that we might be able to knock 30 to 40 million out of their annual budget for operating this aircraft. So we think there's some real significant opportunities for someone. And we didn't even do the math on saying, let's eliminate 5 different types of aircraft and just use this one. And the aircraft has capabilities. We were asked, can it be an amphibian? Well, no, we don't see an amphibian in our future, but it'll operate out of a regional strip without any problem at all. It's not fragile. And it definitely will have the ground clearance requirements to fly out of a regional strip. So if you can go in and out, regional carrier of pretty much any kind, you could go in and out in ours. With the exception of, Alaska and some amphibian operations, we think we cover the gamut of maybe a dozen different aircraft types that could be effectively replaced with just this one. So, yeah, there's some real opportunity there. Looking back at the question, yes, we are certainly looking at customers. We're trying to stay focused, but we're trying to keep an open mind. We're trying to be flexible, but stay focused. I know that sounds odd, but it is what it is. But, we certainly aren't going to turn away from an opportunity if we think we can provide an aircraft to that opportunity that benefits a lot of people.
Right.
Yeah, and to Ben's point of focus, we have a multi-pronged approach. As Ben said, we're focused on customers and operators for sure. Those are the end users of our aircraft. I mentioned earlier, we're also focused on suppliers and manufacturing partners to accelerate the move into volume production, as well as to identify and get products into markets, more markets that we simply cannot address all by ourselves that quickly. And now that we've demonstrated the aircraft with a series of subscales and our manned aircraft, our focus, one of our key focus areas is getting into production.
Mm-hmm.
And our third prong is really, as we've all heard the truism, what's really required to make an airplane fly is money. Yeah. So in any startup, in any company that's developing something new, there's always a prong where the company is focused on ongoing funding in order to continue to achieve their milestones and get to a point where they're sustainable. So for all those that are listening today or those that are listening to the replay, if there's interest in working with us and lending a hand on any of these objectives, we look forward to connecting with you and accelerating the move to the aircraft being in commercial production and addressing as many markets as possible. I often compare this to when I first saw or I first heard about a Sony Walkman in the days of the big cassette players, and they had built-in speakers. And somebody was trying to explain to me why you only needed such a tiny cassette player. Yeah, it ages me. A Discman, same thing. Or MP3 player, whatever. Mm-hmm. And I didn't get it. I really didn't get it until I actually started to use the Sony Walkman, and it's like, oh, this is personal. Nobody else has to listen to what I'm listening to, and so I can listen quietly, or I plug it into some amplified speakers, and then we can share the sound. But because this is very new and it's addressing markets in a different way that haven't been well addressed, we think that there are some really unique applications that the aircraft is going to satisfy. And we look forward to hearing from people and partnering with other companies to address these cool new markets. But we're going to remain focused on the key attributes for us, while also working with those without distracting our focus too much.
Right. So let me jump in. I've been scanning the chat and I saw a couple of things. One, Oliver asked, did you design it from scratch? Yes. This aircraft is a from scratch. It's taken quite a number of years to develop the concept, to test the concept. So we feel like we've really honed this down. It was designed specifically around the idea of combining known aerospace, aerodynamics, supported by mathematics, technologies into a single airframe to see if that airframe can produce dramatically better performance. And it did. And yes, we do have a manned aircraft. And yes, it has flown. It's done taxi tests. It's done some laminar flow testing. So we do have a manned aircraft. We have 3 others at scale. So we know it works. This isn't, we've only drawn it on paper kind of stuff. And we've done a lot of, as Michael mentioned, modeling to make sure. So we certainly appreciate these comments. Somebody else commented about manufacturing processes, which is my bailiwick. I've spent a lot of time in manufacturing in aerospace across the world. And yeah, I think there's a real opportunity to dramatically change the acquisition cost of the aircraft and the maintenance cost of the aircraft by applying a lot of technology and a lot of process improvements and modern concepts to the actual manufacturing process. So instead of doing what's happened to a lot of aircraft companies now, where you're applying modern bill of material management technology to a very old aircraft, so you basically took paper and moved it to a computer, we think using a digital twin, we can go the opposite way. We can take our digital twin and our partnerships with the manufacturers and the subassembly providers, and really understand how to build this plane from the ground up in an effective and efficient way to get the performance that we want, which also means we can create aerodynamic shapes that would be almost impossible to do with aluminum, and even in some cases, composites.
Right.
Very difficult to create the kind of shapes that we think offer us unique opportunities to create a very advanced performance. So yeah, someone
There's one
asked how fast
question.
have you flown the prototype? I don't think we'll address that right now. The person that flew it, you know, got a little aggressive, yes, and we actually had one of our prototypes outrun our chase plane, which reduced the amount of testing that we could do. But we're not going to go into too much detail about the, you might ask the pilot once
Did you have
once we
Tom
go
Cruise
public.
flying your airplane?
What's that?
Did you have Maverick flying your airplane? And
No, but one of the prototypes, we went up there with a chase plane and we got to about 50% and the thing just blew the chase plane out of the sky. And we thought, okay, our numbers are closer than we thought.
Absolutely.
So it does fly, and it flies well.
There's one question that I think is an important clarification or misconception maybe among the types of innovative aircraft that are out there, and that is, have you considered integrating with VTOL? And I think people may not understand the distinction there. Michael, did you want to?
Sure.
We
as I said, we're trying to maintain a focus, and that focus is on a conventional takeoff and landing, a CTOL. We have talked to a number of folks about VTOL integration, and we've had those discussions actually for several years. So we would like to maintain, I think, our focus on CTOL. However, if there is a VTOL company that would like to work with us, I'm sure we can find an arrangement that would allow them to, do the modifications. But our focus right now is on initially a CTOL. If we end up not partnering with someone, we will likely eventually do a VTOL. But I think there's enough CTOL markets that's our initial focus. And particularly in the unmanned area, there's a lot of people doing some really interesting VTOL aircraft, and we'd be happy to partner with some folks on a VTOL version. But as I say, our focus is CTOL. The CTOL provides greater efficiency. By going vertical, you're going to be less efficient because it requires so much energy to get airborne. And so our focus is ultra efficient aircraft, which means we're focused on CTOL. But we understand there are missions that require vertical. Happy to partner with folks on that.
Absolutely. One other really important question. This is probably a rabbit question. Which rabbit are you going after first? So can you advise the target technical goals, speed, load, operating cost, selling price, or all of the above?
And I'll take that one quickly too. And the answer is we're not prepared to answer that today. You've noticed, I think, that we've had a real focus on manufacturing and working with manufacturing potential partners to get something into service. So we will have we'll be able to answer that question very soon, but we're not prepared to answer it today.
Fantastic. All right. So, and I think most of those are kind of, a lot of the other questions are kind of falling into those real specific categories of rabbits, technical rabbits and or market rabbits. So.
And I'll say again, we would love to answer those.
Mm-hmm.
There's just a certain amount that we feel we want to reveal at the right time.
Yeah.
Certain companies, don't talk about things until they make the product release. Other companies leak information along the way and get chatter. Mm-hmm. There's pros and cons to both approaches. At this point, we've taken the approach that we're going to keep things mostly quiet until we're ready for the product release. But by having the event today, we're doing a little bit of let's start some chatter. So There's a balance there, but many of the questions we're not quite ready to reveal. And I really look forward to sharing that information, because I don't like keeping secrets, and we would like more people to be talking about what we're doing. So please be patient. We look forward to answering all those questions soon.
Absolutely. There's always that balance between Oh, go ahead, Brian.
No, go ahead. There's always a balance. And then
Oh, yeah, I was just going to say there's always a balance between, transparency and responsiveness, and protecting the business so that it becomes economically viable. And so, that's the struggle that every innovator comes up against, and, every innovative company comes up against, is how do we manage that? So
So
Ben, yeah.
I just wanted to thank, there's a bunch of people that have took the time to type into the chat. Michael, and I think it's Les, and pardon me if I don't pronounce your name right.
Hmm.
Dennis, Mac, Oliver, Bradley. We
Hmm.
had this great conversation going on in the chat. Jared, Grant, this is fantastic. We really appreciate your engagement. I know we're running down the time, and I want to make sure that we don't keep you. Like we did say, the recording will be available, and I know Paula will give us a wrap up here in the next 30 seconds or so, so we'll finish on time. But Michael and I, it's just been great to talk about the plane. We haven't done a lot of public discussion about our airplane, and we want to change that. We're getting pretty close to production now. We're talking to customers, talking to suppliers, and we think it's time now for the public to know that we exist, to know that we have something that can really benefit a whole range of markets, and that we're open to having conversations with customers, with suppliers, with people with good ideas. And that's one of the reasons we're here. We are thinking of doing some more of these. So we're going to do at least one that's more targeted towards the Asia Pacific timeframe. We have been talking to people in Asia Pacific, and not many of them wanted to get up at 4 a.m. to do this. So they'll listen to the recording, and they've already asked for it. I'm getting texts now from yesterday, rather, that said, "Hey, don't forget to send me the recording." So we're going to move it into the afternoon next time. But we're certainly interested in engaging in interesting topics and talking about our plane. So if you have some ideas and you want to put them in the chat quick before we wrap up, that's great. Or you can reach out to us on LinkedIn and send your comments that way through our company page. So Paula, please take us out.
All right. Well, I will almost take you out, and then we'll give Michael the last word, but it will take LinkedIn some time to finalize and publish the recorded video. So feel free to review the recording, and please share it with your friends, neighbors, colleagues, anyone that you think is interested in this project. And I love the conversation that's going on in the chat. I mean, Jared answered Michael's question, and I mean, it's just really cool to see the community gathering around this project and helping with that. So that is amazing to see people really engaging. You can add additional questions and comments after the event. You can continue to discuss this as you review the recording, and new people, as they are reviewing the recording, are going to be coming up with new questions. We'll hold another event in about a month, so we'll use any questions or suggestions that we didn't get to today for future sessions and answer them again as much as we can. Please let us know what you'd like to talk about in future sessions. Anything that you'd like to see different about the mechanics of the session or anything else. And yeah, let's let Michael take us out.
Okay, thanks, Paula. So we're at the top of the hour. Thank you all for attending and for your participation in the chat. I've certainly enjoyed the time together. We're excited to connect with people and organizations that can help bring our revolutionary aircraft into production and beyond. If you'd like to lend a hand, provide an introduction, please reach out through LinkedIn, as Paula said, and you can do that by searching for DBT Aero in the search box. I'll close by saying, whether your interest is in providing suggestions and ideas, joining our team, becoming a customer, a manufacturing partner, a stakeholder, or an evangelist, let's talk. Again, thank you for attending. We look forward to continuing the conversation again soon. I hope you all have a wonderful day or evening, whichever part of the world you're in. And with that, goodbye, and look forward to seeing you again soon. Have a good day.
Thanks, everyone.